Today my topic is ARM architecture in embedded system and IoT designs. What is ARM architecture? ARM is advanced RISC machine. The major two domains the ARM works is mobile devices and embedded systems. Due to their scalable computing techniques, energy efficiency, widespread adoption in industries, and versatility. In this video, we can see about the architecture, features, advantages, and limitations of ARM architecture. As we already seen in the previous part, what is ARM? ARM is an advanced RISC machine. ARM processor or control is used for commercial purposes. And applications of ARM are mobile phones, modems, video games, handycams. Features of ARM are architectural simplicity used for small implementation. ARM process used for many PCs and laptops. Now, here is a history of ARM architecture. ARM architecture is developed at Acorn Computers Limited at Cambridge between 1983 and 1985. At Inkland in Cambridge City, the ARM architecture was introduced in the year of 1983 to 1985. In ARM architecture, we using reduced instruction set computer. Why we are using RISC rather than CISC? RISC is known as Reduced Instruction Set Computer and CISC is known as Complex Instruction Set Computer. In next slide, we can see the comparison of both. Here is the major comparison. RISC is more competitive than CISC and easy to develop, cheap compared to CISC Complex Instruction Set Computer, and the risk pointing the way to feature is more than CISC. As we seen in the previous slide, RISC versus CISC. RISC is reduced instruction set computer and CISC is complex instruction set computer. Here is the comparison of CISC and RISC. CISC emphasis on hardware and RISC is emphasis on commonly in software. Multiple instruction sizes and format, instruction of same set few formats. CISC has less registers, RISC has more register than CISC. More addressing modes are in CISC and RISC contains fewer addressing modes. Extensive use of microprogramming. Here is a complexity in compiler. Instructions takes a varying amount of cycle time. Instructions take only one cycle time in reduced instruction set computer. These were the comparison of RISC and CISC. In the slide, we are going to see about the versions of ARM architecture and features of these ARM architecture. Here is the some features and some of the versions. Versions are Broadcom BRCM 5000, ARM Cortex A9, ARM Cortex A9, Intel Atom CPU, MIPS 74K. The features are design type, instruction set, CPU speed, issue rate, reordering, multi-threaded, pipeline depth, L1 cache, special instruction, and some of the core mark and CPU power rate. Here, the design type of an Broadcom BRCM 5000 is hardcore. In ARM Cortex, it is hard and Osprey. In ARM Cortex A9, it is softcore. In Intel Atom, it is hardcore, and MIPS, it is soft. Instruction set of these versions Broadcom MIPS 3.2 in ARM Cortex ARM v7, in ARM Cortex A9 ARM v7, Intel Atom 86 to 64 bits, and MIPS MIPS 332. Commonly, Broadcom BRCM and 5000 and MIPS 74K is more equal. The issue rate is 2 per cycle, 2 per cycle. All the versions have 2 per cycle. And it has reordering or not. Broadcom BRCM has no reordering. ARM Cortex 9 A9 has reordering. Intel Atom CPU has no reorderings. And the special instructions in Broadcom BRCM 5000 is DSP FPU and ARM Cortex A9 is DSP FPU Neon Jacel. Jacel is used only for JavaScripts. ARM architecture A9 uses same DSP FPU Neon Jacel. Intel Atom CPU uses SSE3 FPU. MIPS 74K uses DSP FPU. These are the versions and features of ARM architecture. In the slide, we are going to see about some of the features and relation to the ARM and some instructions. First, based on Berkeley RISC machine, it has a fixed length instruction and supports the concept of pipeline. Load and store architecture by using the register. This load and store architecture is mainly used in ARM architecture. 32 bits architecture, including address bits and data bits, are used in ARM architecture. Relation when used in relation to ARM. There are three relations to ARM. Byte means 8 bits. Word means 32 bits, that means 4 byte. Half word means 16 bits, that means 2 byte. The instruction set of ARM architecture is 32 bits ARM instruction set, 16 bits thumb instruction set, and JASL. As I have said in a previous slide, JASL only used for Java coding. These are the features and relations and some of the instruction set of ARM architecture. Next, we can see the block diagram of ARM architecture and explanation of the block diagram. This is ARM organization block diagram. ARM organization, in this block diagram, we are going to see about how data is flowing, how we are getting the data, and how the data is executed, and how it's managed internally. In this block diagram, it contains address register, add increment, register bank, multiplier, barrel shifter, ALU bus, PC bus, increment bus, A bus and B bus, data out register, data in register, incrementation decoder, and control logic. We can see the execution of data. In this block diagram, register bus means it handles or it holds all the local register in it. And barrel shifter will shift to right or left or rotate the data. Here, register bank is connected to A bus and B bus to ALU. A bus is directly connected to ALU, but B bus is not directly connected. Here, A bus and B bus is known as data bus. A bus, the execution of registered bank is denoted as RM in A bus, and execution of